and doesn't repeat, so it's irrational and real. And number 5, negative 15 over 3, that's negative 5, so it starts at integer. So it's integer, rational, real. You can write the word, you can write the symbol, it doesn't matter. Are there any questions on how to classify, what to classify, how the chart works? When you classify, start at the bottom. So you want to find the most specific answer and then go up. So everything above works. Online, guys, do you guys have any questions? Okay. All right, I'll leave that up there for you guys. We're going to continue to page 2. We're going to do imaginary, even, odd, prime, and composite, and then we'll do our first practice. All right. Anybody still writing? Still need it up there? Okay. What's an imaginary number? Square root of a negative. So back in Algebra 1, you were taught that you can't have imaginary numbers. When you type in the square root of negative whatever on your calculator, it gave you like an invalid answer. It said non-existent. They do exist. So you can change them in your calculator by going into mode and changing it to real. So what that looks like in your calculator, let's see if I can get that without a glare. There it goes. All you do is press mode and go down to where it says real. And if you downloaded any of the calculator apps, you can do this on your phone. And then you just arrow over to A plus BI. You can do any kind of math in imaginary mode. So you can still do 2 plus 2. It will still work. So it's not just for imaginary numbers. It just lets your calculator say, okay, I recognize that imaginary numbers exist now. Now I can square root negative numbers. So until you tell your calculator to do it, it's going to tell you that you can't. Okay? So an imaginary number is just a complex number. Okay, it's a complex number that can be written as a real number multiplied by I. So a lowercase I is represented as an imaginary number. I'll zoom out for you. Yes. So lowercase I. Did you guys see this in Algebra 2? Or was this whenever school shut down? Does anybody recognize I? Yeah. Okay, did you guys work with I a lot? Did you have a lot of time? No? Okay, that's okay. In the ACT, there's not much about it. It's very basic. It can pretty much all be done on your calculator. So I'm not going to spend time teaching you things that aren't on the ACT because you've already taken those classes. Our goal is to get you prepared for the ACT, and I want to teach you what's on it. So what's the square root of negative 36? 6i. So remember, whenever you have the square root of negative 36, that's the same thing as having the square root of 36 times the square root of negative 1. So you can break apart square roots by multiplying. Okay. Then you just take the square root of each of them individually. If you know your perfect squares, you can look at that and kind of separate it in your mind. But if not, this is all that you're actually doing. You're square rooting the perfect square, and then you're square rooting negative 1. So the square root of 36 is 6. The square root of negative 1 is I. And that's it. So the negative square root, we just write as I. And the negative square root, we just write it as I. And that's it. That's pretty much as complicated as it gets. Your calculator can do a lot of this stuff. So if you type in negative 36, the square root of it, it's going to give you 6i, as long as it's in imaginary mode. Okay? Does anyone remember the rules of I? What's I to the first? No, it's not 0. It's not 1. It's okay. It's been a while. It is I. The square root, or I to the first is I. Anything to the first power is itself. What about I squared? -1. I to the third. It has an I in it, but it's going to be -I. So I to the third is -I. What about I to the fourth?
Isn't it just 1?
It is just 1. Good job, Stephen. 1. Good job. Now, this pattern repeats every 4. So I to the 1, 2, 3, 4. If I have I to the 5, I just start back at 1. It repeats every 4. So when you're trying to find what the imaginary value of a large exponent is, you just look at the last number. So I to the 525. What's our last digit? 5. So what you do is you pay attention to this value. So I'm just going to count. That delay is strong. 1, 2, 3, 4, 5. So it's just I. So anytime you do this, pay attention to the last number. Now, when the last number is 0, we'll talk about what to do. So what about I to the 23? Yeah, -I. The last digit is 3. So I'm just going to count. 1, 2, 3. And that's just -I. But I to the 48. 1. Because 4, 8. You can just count. 1, 2, 3, 4, 5, 6, 7, 8. Our last number is 8. I don't know why it's so delayed. All right, I to the 26th. -1. So I to the 26th is the same thing as just I squared. I would just count to 6. Now, when the number ends in 0, you can't count like that. If the number ends in any number other than 0, so 1 through 9, you can just count. If it ends in 0, it's going to change a little bit. So the way we're going to do this, let's do some practice. We'll do I to the 20 and I to the 30. We'll do 2 practice problems. So your calculator can usually handle small exponents. It doesn't get overwhelmed with tinier exponents. So you could try to type it in your calculator. It'll probably work. Okay? Or we can practice using division. Okay? So since the I pattern repeats itself every 4 times, remember when you used to divide in like elementary school, you had a remainder of 1, a remainder of 2, remainder of 3. You're going to use that same idea to help you with I. So what you do if the exponent ends in 0 is you take the whole exponent and divide it by 4. Okay. So the reason we divide by 4 is because it repeats every 4. So we're looking for numbers that are divisible by 4. So what's 20 divided by 4? 5. Do we have a remainder? No, so I'm going to put 0.0 here because I have no remainder. What that means is I to the 20, if I have a remainder of 0 or I get a whole number, your answer is going to be whatever I to the 4th is. So I to the 4th is 1 because what that means is I could keep counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You end up at I to the 4 every single time. So if it goes in evenly, your answer is I to the 4th. So it's just 1. If it goes in evenly, it's I to the 4th because it's divisible by 4. Let's try I to the 30. You take 30 and divide it by 4. So what's 30 divided by 4? Okay, 7 with a remainder of 3, or 7.5, right? So 7.5. Okay. 0.5 is 2/4. Does that make sense? A half is 2 out of 4? Right. So I'm going to use I to the 2 because it's out of 4. So if you're solving these problems and you get decimal answers of 0.5 when you divide by 0, it's going to be I to the 2nd because 2 divided by 4 gives you a half. If you're solving and you get 0.0 or a whole number, it's I to the 4th because it goes evenly. Now, this is only, you can do this for any of them, but only I to the 0 when it has a 0 at the end, you want to use that trick. All the other ones, you can just count. Right? Also, your calculator should tell you how to do this. It should give you the answer, as long as it's in the correct mode. Do we need to try a couple more of those with zeros? Anybody need another example of those? Okay. Let's try even odd. So we talked yesterday about how the ACT will like to trick you by taking away your numbers and giving you definitions instead. So what's an even number? Okay, 6 is an even number. What makes that even? It's divisible by 2. So divisible means I can divide it and I get no decimal. Okay? So an even number, it's divisible by 2. That's like a middle school topic. It's been, a long time since you've learned that, but it's just kind of a math fact that you need. What makes it odd? It's not divisible by 2. So if you divide it by 2, you get a decimal, like 7. 7 divided by 2 is 3.5. So not divisible by 2. So divisible just means that I'll get no remainder. Okay. So let's talk about a way that the ACT can make a problem hard. So in terms of even and odd, 1 plus 3 would give me what type of number? Even or odd? An even number, okay? 1 plus 3. So if I have 1 plus 3, my outcome is 4, which is even. The way that the ACT makes that difficult is they take the numbers away and describe the numbers instead. So the ACT would say, an odd number, like A and B are odd numbers. What is A plus B going to equal? And you're going to sit there and go, well, they didn't give me any numbers. I have no idea. But all you have to do is think about even versus odd. So you can do all of these problems. Just think about the definition. Okay? So let's start with odd plus odd, which is what we just did. An odd plus an odd will always give me what outcome? An even number. 1 plus 3 is 4. That's even. You could try it with another one. 5 plus 3 is 8. You can test it if you want to, but any odd number plus any odd number will always give you an even answer. What about an even plus an even? Yeah, even plus even is even. 2 plus 4 is 6. It's even. What about odd plus even? That's an odd number. 1 plus 2 is 3. 3 is odd. So just by kind of practicing the math facts, it's going to make problems that seem difficult, that have no numbers, really easy to understand as long as you know the vocabulary. Let's try multiply. Odd times odd. Odd times odd is odd, so just test it. 1 times 3 is 3. 3 is odd. It'll work for any number. All right, even times even. That's even. Okay. 2 times 4 is 8. Okay. And then odd times even. That's an even. 1 times 2 is 2. So these are kind of problems that if you're struggling on the ACT and you take it for the first time, they're the problems that look the most intimidating, but they're really basic. You just have to know your vocabulary. So before we do our practice, we're going to do prime and composite numbers. What is a prime number? It's what?
Isn't it a number you can't use for everything?
That is perfect squares. You're close. What's an example of a prime number? 13 is prime, so what does that mean?
You can divide whatever one by two.
Divide
You can only divide by one in itself, right?
one in itself, right? So a prime number, to multiply to get 13, I can only do 1 times 13. That's the only way I can ever multiply and get 13. Okay? That's different from 6. I can do 1 times 6, and then I can do 2 times 3. So that's the difference between prime and composite. So a prime number is a number greater than 1 whose two factors are 1 and itself. And in this case, we're not going to be talking about any kind of decimal. These are whole numbers like 1, 2, 3, 4, 5. But it has to be bigger than 1. So it's a number greater than 1 whose two factors are 1 in itself. A factor is something you'd multiply to get that number. So the factors of 13 is 1 and 13. 1 times 13. What is the smallest prime number? No, it's 1. It's got to be greater than 1. 3. Okay. 3 is the smallest prime. 7's a prime number. Is there anything lower than 3? 2. So here is the way that you're going to get tripped up in your head. We like to associate the word prime with odd. We think odd numbers are prime, like 3, 7. Those are all odd numbers. They're also prime. However, 2 is also a prime number. How do I get 2 when I multiply? 1 times 2. There's nothing else you can ever multiply to get 2. 1 times 2. That's it. So 2 is the only even prime number. So in our heads, we like to associate prime numbers with being odd numbers, but that's not true. 2 is a prime number because the only way to get 2 is to do 1 times 2. Okay, so then we've got 3. What's the next one? 5. 1 times 5. Then 7. What's next? 11. It's not 9 because how do we get 9? 3 times 3. So that's composite. So 11. What's next? 13. Then what? 17. Because remember, 15 is 5 times 3. So keep that in mind. Prime numbers, don't always associate them with, oh, they're all odd. 2 is a prime number, and we forget that. The way that the ACT will test you is it's going to say, here's a group of numbers. Like, which one of these groups only contain prime numbers? You're going to see 2 in that answer choice, and you're going to cross it out because you're like, oh, 2 is even. It can't be prime, but it is prime. So that's an easy question to miss just by thinking prime numbers are odd numbers. So composite numbers fill in the prime numbers. Composite numbers are numbers like 4. A number I can multiply other than 1 in itself and get. So 1 times 4, then I can also do 2 times 2. So a composite number is a number greater than 1. Again, no decimals or negatives, greater than 1. That can be divided evenly by a number other than 1 in itself. So a composite number basically fills in the missing pieces of the prime numbers. So don't think that prime goes with even or odd and that composite goes with even. There are odd numbers that are also composite numbers. So what's the smallest composite number? 4. Because 2 and 3 are both prime. The next number that's not prime is 4, which means it's composite. What's the next composite number? 6. Then, next, 9. Then, what? There we go. Next.
12,
Okay, next.
15,
There we go. And we can keep going and going and going, but notice what happens. Prime and composite numbers complete each other when they're together. So I've got 2, 3, 4, 5, 6, 7, 8, and so on. Like it fills itself in. A number can't be prime and a composite at the same time. It's not possible. It's one or the other. Okay? So these are all the notes we have today. Are there any questions about any of the words that we've gone back over, any kind of classifications, anything at all? Okay. I'm going to give you a little tab for your binder to keep your notes separate from your worksheets. So online, guys, what you're going to do, I'm going to close this out.